Alright, so today you're going to be finding the roots of equations. And roots are also known as zeros, so sometimes you'll hear roots or zeros, and these terms can be used interchangeably. These are the steps that we're going to follow, so you can pause the video if you need to do that. Alright, so we're going to head into problem number 1. So it says, find the roots of the equation and leave your answers in radical form when necessary. So I know that I have a cubic equation. Since this is a cubic, or a third degree, that means I should get 3 answers. Alright, so I'm going to figure out how I can get all 3 of my answers. So I'm going to make my list of p's over q's. P's are all the factors of 8. So that would be plus or minus 1, 2, 4, and 8. Because 1 times 8 or negative 1 times negative 8, that would work as well. Q is all my factors of my lead coefficient, which happen to be 1. So it's only 1 times 1 or negative 1 times negative 1. Alright, so my p's over q's is 1 over 1, 2 over 1, 4 over 1, and 8 over 1. And any of these can be positive or negative. Alright, so this would tell me that there's 1, 2, 3, 4 positives and 4 negatives. But I know that there can't possibly be 8 answers because it's a cubic equation and therefore it can only have 3 solutions. So I know these are just my possible solutions and they're not really my actual solutions. So to find my actual solutions, I'm going to use my calculator to help me at least get started. Okay, so you're going to go to y equals, and you're going to type in your equation. X to the third minus x squared minus 10x minus 8. Okay, and I'm going to hit graph. If you don't get this graph, you're going to hit zoom 6. Okay, so I can see there's 1, 2, 3 solutions, and actually these should all be numbers on my list. All right, so this, I can count my tick marks, 1, 2, 3, 4. It looks like positive 4 is a solution. All right, so let's figure out which ones look like they cross at the x-axis, which would be, we'll say, look like x-intercepts. So that would be 4. This looks like negative 1 and negative 2. All right, so we're going to actually prove that these are actually our solutions. So let's just start with the number 4. So you're going to use synthetic division, which we did last semester. So you put a 4 here. Not last semester, earlier in the chapter. So you look at your coefficients. We got 1, negative 10, and negative 8. All right, and then I'm going to drop down the 1. 1 times 4 is 4. Add, I get 3. 4 times 3 is 12. Add, I get 2. And 4 times 2 is 8. And I add, and I should get 0. So this tells me that my remainder is 0, which means that this number 4 is definitely a solution. So if the number 4 goes in, it means x minus 4 would be a factor, and therefore there should be nothing as a remainder. All right, so that's a good thing. So now you're going to ignore all of this stuff and the 0, and you're going to do synthetic division again with just the 1, 3, and 2. So try the other number that you have that works. Negative 1. So we're going to drop down the 1, multiply, you get negative 1, add, you get 2, multiply, you get negative 2, and you add, you get 0 as a remainder again. So that tells me that negative 1 works. So far we've checked that 4 and negative 1 both work. And then you're going to try one more time, negative 2. And you just do it with the 1 and 2. So bring down the 1, multiply, you get negative 2. And as long as 0 is my remainder, then I'm good. All right, so this tells me that my solutions are, my roots, are 4, negative 1, and negative 2. All right, so you do need to use the calculator to get started, but then you have to show your work and prove that they actually are solutions. All right, so flip to the next page. All right, so we're going to follow the same steps. Okay, so we're going to make our p's over q's list. And again, I have a cubic, so I should get 3 answers. All right, so all my factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And any of them could be positive or negative. Q's are factors of 1, so that's just 1. So my p's over q's list is just 1 over 1, 2 over 1, 3 over 1, and so on. But any of these could be positive or negative. So this leaves me at 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16 possible solutions. But we know that these are not all going to work because we know we only have 3 answers. All right, so again, you're going to use your calculator to get started. All right, so we're going to graph and we're going to find x-intercept. So go to y equals, type in your equation, x cubed minus 6x squared plus x minus, no, plus 24. Double check that you have it in correctly. All right, so if you hit graph, now this time, this one looks like it's almost at -2. If you hit trace and type in -2, you can see that it's really not at -2 because -2 comma 10 is way down here. So this is going to be like something close to -2, but it'll be a decimal. All right, this one looks like 1, 2, 3. So if I hit trace and type in 3, then I know for sure, if you notice it says 3 comma 0. So my x-intercept on my calculator looks like it's at 3. And this one is in between 4 and 5. So all these are whole numbers, so it can't be anything between 4 and 5. So that means we're going to have to use synthetic division and then do another method of solving, which is in step 4 here. So you're going to use the 3 with your coefficients from the original equation. So 1, -6, 1, and 24. Now remember, you should get 0 as a remainder. So if you don't, then you did something wrong. Hopefully we don't do anything wrong. All right, if I multiply, I add, and I get 0 as my remainder. So that's perfect. All right, so synthetic division, remember, if this was a cubic, these numbers represent 1 degree less. So this is 1x cubed, this is 1x squared, minus 3x, minus 8. All right, so here's my equation. I'm going to just set it equal to 0, and I need to solve. I can either solve by factoring, quadratic formula, or square root method. Well, I can't use square root method because I have this 3x, so that's not going to work. Factoring, I would need something that multiplies to 8, -8 that adds to -3. So that's not going to work either. So I need to use the quadratic formula. So you can either do quadratic formula by hand. Here's our quadratic formula. All right. I guess we can set this one up by hand, and I'll show you how to do it on the calculator. So opposite of b plus or minus b squared minus 4ac all over 2a. So you get 3 plus or minus, this is going to be 9 plus 32, which is 39, and all over 2. All right, so my solutions, remember I was supposed to have 3 answers. One of them was 3, right? And another, so my roots are 3, and then there's 3 plus root 39 over 2, and 3 minus root 39 over 2. So those are my 3 answers. Okay, but let me show you how to use the program on our graphing calculator. So if you go to program, and there's this program called AQuad2, and you just hit enter maybe 3 times to get to here, and you choose quadratic formula, and you want to solve, so you just enter in a, b, and c. A, b, and c are 1, -3, and -8. And hit enter. And we want a radical answer. So, I can't add, sorry. So 9 plus 32 is 41. Good thing I used my calculator to check. All right, so now you can see we have 3 plus root 41 over 2 and 3 minus root 41 over 2. Sorry about that. Good thing we used the calculator. All right, so we're just going to exit and quit out of there. All right, so let's look at number 3. Okay, so first thing is it's not equal to 0, so you have to subtract 6. You get x cubed plus x squared minus 5x minus 6 equals 0. All right, so I'm going to do my p's over q's. P's are factors of 6, so 1, 2, 3, and 6. Q's, again, are factors of 1. And my p's over q's are 1 over 1, 2 over 1, 3 over 1, and 6 over 1. All right, so I'm going to look at my calculator and see if I can find an x-intercept that is on my list. So it looks like -2 or -1. So I'm going to hit trace, and it's -2. It's not -1. And this is in between 2 and 3. So we said -2 is the one that worked. So on my calculator, I found an x-intercept of 2. That's my synthetic division, and I'm going to use the coefficients from here. All right, so bring down your 1, multiply, and add, and negative 2. See, I knew I wasn't getting 0 as a remainder, so I knew something wasn't right. So this should be negative 2. This is negative 1. This is positive 2, negative 3, and there's 6. So you should always get a remainder of 0, and that tells you that this is definitely a solution. All right, so this is a quadratic, so 1x squared minus 1x minus 3. And then I'm going to use my A-quad program just to make it faster. And I'm going to type in A, B, and C. So 1, negative 1, and negative 3. And I want a radical. So my answers are 1 plus square root of 13 over 2 and 1 minus square root of 13 over 2. And remember, you're supposed to have 3 answers, so there's 1, 2, and don't forget negative 2. Those are all my roots. All right, last question. So everything's equal to 0, so we can go ahead and list our p's over q's. So factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Now, a lot of factors there, but the q's, there's only 1. So it's p's over q's, which are just all the numbers that we just had in our original list. Now, all these problems that we just did, all the q's were just factors of 1, but sometimes you'll have a lead coefficient that is not 1, so you'll have more numbers and more fractions in this list. All right, so we're going to look at our x-intercepts on our calculator. You have to exit out of A-quad if you used that. So go to y equals, and we're going to type in our equation. So x to the third plus 3x squared minus 16x minus 48. And I'm going to hit graph. All right, so it looks like positive 4, negative 3, and negative 4. All right, so I'm going to write all those down. Positive 4, negative 3, and negative 4. All right, and even though we found our answers, you have to just prove it with our synthetic division. Okay, so I'm going to start with 4. Doesn't matter which one you start with first. So I got a 0 as a remainder, so that's good. And I have 1, 7, and 12. If I don't want to keep going with synthetic division, I could just say that this is 1x squared plus 7x plus 12. And then I could factor what multiplies to 12 that adds to 7. And then remember, you just set each of these equal to 0. So that would be a way of avoiding the quadratic formula, which certainly you could use. But you could also solve by factoring. And if you don't want to do that, you could just continue with your synthetic division. So I guess it's your choice what you would prefer to do. And there's no right or wrong method. All right, and then I'm just going to continue my synthetic division and make sure that I get 0 as my remainder. And as long as I do, then I'm good. So these are my 3 solutions, 4, negative 3, and negative 4.